So welcome back to another Python class, guys. And last time we talked about ETL pipelines and how you can do or build your own actually in Python and Postgres. That was task number 13, I think. And now we are back, and I want to introduce you to the next step, which basically is a module which is called Pandas. And we will have a different environment today because I'm going to show you how to work with Jupyter Notebooks, or aka Jupyter Labs as well. And I also will explain to you what that actually is and why it's so interesting, okay? And before we do that, I need to switch my screen and open Discord so I know that you're here, guys. And if you have any questions, just let me know, okay? So I can check it out. But yeah, so let me just switch my screen. And you can see here, no, let me actually start from this point. So this is, as you can see, or the familiar environment, which is PyCharm, which we always have used before. And today I just wanted to show you how to work with data frames, but now you basically don't know what that is. And I just wanted to start from a point where you actually know where we are, right? And right now we are just in PyCharm, and I will explain to you what you can do with pandas and what that all is. But here's a very quick example how I created this table here at the bottom, as you can see. So it's completely random, but this has been generated by just using pandas, which is the module which we're looking at, and NumPy, which is an additional module, but it's not that important today. For now, you just need to know NumPy is another module which is used for complex computations and to work with data, like heavy data, and to do a lot of calculations. And we just said we want to create random data structures between specific numbers. Okay, so that's basically it. But all you need to know is now, but just by using this line, you see, we created this whole table. And that's a totally new data structure which you haven't seen before, because we want to go away from just simple lists which you have used before and dictionaries, maybe even sets, right? And if you come from object-oriented programming, maybe you also know structs, which are a special data structure which you can define yourself. But today we work with pandas, which is like one of the most important data structures for people who work with data, which are data analysts, data engineers, data scientists, or just people who want to analyze data at all. And they actually are web developers, or it doesn't matter who you are actually, right? But people who really love to work with data, they need to have some kind of form or format where they can actually look at the data, right? Because if we look at, for example, let's say we want to look at all the data of a specific field, which could be all the transactions of the Bitcoin blockchain, or all the messages from our self-test server. It doesn't matter what it is. And imagine we would start by just or stick to lists and dictionaries, which we know before. Then it would look like a huge chunk of data, right? And I looked for some example which can visualize this more. And imagine you have to tell somebody a story with just this huge chunk of wall of text. And you're like, oh yeah, look at this. We have this ID with the login Herman something and his Gravatar ID, and he's a very important person because of this data. Here you can see blah, blah, blah. You know, you can't even see that, right? Because it's so big. And this is a huge list of dictionaries, which are, I don't know, which is some random data which I found on GitHub, which is from this repository at the bottom, if you can see. But you see, this is very bad, right? So this, you can't tell any story with that. You can't highlight any insights out of that data structure. And that's why we want to go into data frames today. And to do that, we need to understand like how it's connected to what we actually did before. And I prepared this whole notebook for you, which is called Jupyter Notebook, okay? Because what you used before now is just an IDE, which is called PyCharm, Visual Studio Code, or whatever that is, and you have this file tree at the left, and then you have editor here, and then your output maybe in your terminal, or you have an extra window, whatever that is, right? And then you have your debugger and all that stuff inside, which you can use because it's such a high performance environment. And now we have something else which is called Jupyter Lab, okay? And you need to install that actually, but today we are not here to learn how to use Jupyter Notebook or something. It's just something which you have heard about, and I installed it on my computer already, and you could do the same by just going to your terminal, and then you could open a virtual environment, of course, like I have shown you before. Like you can say Python 3 -m, and then you say and playground, which I always refer to, but I did that already. And let's say I want to go to that to open it, because you need to open Jupyter from your terminal as a module. But it's not that important. I just want to show you how it looks like. So let's go to my environment, which is called Van Playground. And then I have to write scripts and activate. So I just activate it on my Windows PC and go into my virtual environment, which is called Van Playground. And now I just want to see if Jupyter is installed. And to do that, the easiest way is just to freeze your pip modules, which you have installed. And because my playground is the environment which I always use to play around, I probably have a lot of modules here, so don't be shocked about that. And the only thing I care about is to look for Jupyter Lab or something which is called Jupyter, because here, look at this. You can see Jupyter Lab, right? And if you want to use it for yourself, you can say pip install Jupyter Lab just like that. But I did that already. That's why it says, yo, you already have it, or whatever that is. Oh my God, pip install. Install. So then you can see, what is this? Where does it say? Something like that. No much for this. Oh my God, maybe it doesn't find it like that. Yeah, I forgot how I installed it, but I think it was Jupyter Lab or Jupyter Lab, whatever that is. But now you see I installed it, and if I want to start it, but I already did it, I could write Jupyter Lab, and then it would just start an instance on my local PC, and then I would be able to go into my browser, go to localhost 888 here at the top. If you could see that, I think you can't see it, but it would look like this. Wait, let me just open here a new cell. So you see it actually looks like that. And then I can open it, and then it looks like that. And then I have my Jupyter Notebook opened, and this is basically the platform or the IDE which every data scientist works at or on. And it actually looks like a normal environment, like an IDE as well, because as you can see here on the left side, you have all your file trees, your files and folders, whatever you want. And then on the right side, you have your editor. But now I just folded all of them so you don't see them. But yeah, that's basically Jupyter Lab, and that's where we are working on today, because it comes with a couple of nice features which we don't have in Python, like in PyCharm or Visual Studio Code per se. Because, for example, let's just say I close this window now just to have it cleaner. And let's say we want to say print my name is long, right? And now I would have to go into PyCharm and press play or right click, run, or whatever that is. Like I could click this button here, and then it would run the selected cell. And then my output would be printed here. Very simple. But what I like is I just press Shift Enter, and then it runs that. Like here, look at this. Boom. And now I see my output immediately. So I don't have to do anything else. And this environment is really good to explore your data, right? That's why we're using it right now, because when you work with data frames, you will see why it makes sense to use such a platform, okay? And now I just show you what we actually know, because this is the start where we are taking off today. And what you know is this data structure. I don't know if you can read that actually, but I hope. So this is basically, actually I should start before that, because you can see this is a cell here which is highlighted in blue, which is like your working field in this notebook, because it's like a scratching book where you can have a lot of different cells and they all run individually, or you can run them all sequentially in one run. Okay, but now I just created one field like you have seen here before. I just created one here, or I just go next and say I want to create all of them. And you can use a lot of shortcuts to move in this environment, but it's not that important today, okay? It's just I want to show you what data scientists do actually, and then we learn a new data structure. But now let's revisit what we know. So this is a list which you know before, so it's here indicated by those square brackets, and then we have another list here and here. And if we want to make a dictionary out of that, it's pretty easy. So you have to start with square brackets. Is it square bracket? Square, no, curly brackets. So that's what I did here. And then I just say, okay, I will just create a new dictionary, and I start with those curly brackets. And then, as you know, we have a key and a value pair, right? This is a dictionary which we have seen before. So we have a list here, and then we have a key. And now I just said, okay, I want to have a dictionary which basically consists of the category, and then I want to add all the fields from this list into the values for this category, right? So that should be pretty straightforward, what you have done before until now. And maybe I can also just tell you that I could copy this and put it here as well, but then your whole cell or your whole your dictionary would be too big. That's why we always like to keep it clean. And remember, when we write code, try to not repeat yourself and write as modular as possible. Because imagine you want to change the fields, then you just go here on top, and then you say, okay, I just want to add a new field inside this list or whatever that is. Okay, it's just a small reminder. And if you noticed, we have all lists have 4 elements in their list, right? So 1, 2, 3, 4, 1, 2, 3, 4, and that's on purpose, but you will see why. So I just created the dictionary, and here I just press Shift Enter in my first cell. Nothing happens, you see, it just executed it. And if there would be a star here where my mouse is, then it would mean, okay, this cell is busy, it's currently busy doing something. And here's another thing which you have seen before. So I actually could also say this cell is a markdown instead of a code. And that's why it looks like that. And then I run it, and then it's a title. That's why this is super cool as a notebook. And it's also really cool to use to show people something in your program or whatever that is. But remember, or take this as a note, you don't write software in a Jupyter Notebook. You could do that. There are infrastructures also on the cloud how to do that, and they can run from your Jupyter Notebook, but I don't know anybody who does that actually, and I think only very advanced people know how to handle all of that. But it's a very specific specific topic. Anyways, so we created this dictionary, and now I just press Shift Enter again, so I can process what I did in this cell. So you see, I just press Shift Enter, nothing happened because it processed what I wrote without problems. And now I could say, or what you normally do is you say print my dicts, so you actually know what you did, right? So I do that again, and now this dictionary has been printed. But another feature of this cell is that I basically just could write my dictionary here without print, and then I will just get my variable output, as you can see here. And it's even a little bit more formatted than if I just say print like this, print. You see, this is a little bit like harder to read than if I just say my dict, boom. And that's like the first thing you have done so far. So you just wrote your whole dictionary into or two Jupyter cells, right? And now let's go into Pandas. So I told you before, this is a very bad way to show people, hey, look at this data, this is amazing, or whatever that is, right? And that's why we want to go to another data structure which helps you to tell your story of your data better, or to help you to analyze and understand your data even more, and to have the possibilities to manipulate and work with your data even more. Because when you use Pandas, you get so many tools and methods which actually can help you to save time while you process your data, okay? And now I'm going to show you how that actually looks like. So here's just a quick explanation which I wrote for you from, I think it's from W3 or whatever that is, that page. And Pandas is a Python library used for working with data sets. Okay, that's clear. It has functions for analyzing, cleaning, exploring, and manipulating data, right? And the name Pandas, that's very interesting, has a reference to both panel data and Python data analysis, and was created by Wes McKinney in 2008. So that's why it's called Pandas, actually, which is really funny. So now, if you want to use that, you have to install the module which is called Pandas. And remember, we just can't stick to this, or we say as PD, which most people do, because you don't want to write Pandas all the time like this. So just PD, and then that's fine. So what do we have here now? And then I also imported NumPy, and normally when you work with Pandas, you will have the possibility to also work with NumPy, because I told you before, it's used to help you processing and working with a lot of calculations. Like this is actually used by people like who work with a lot of statistical data, or they do a lot of calculations and math or whatever that is, but we actually don't use that. I just wrote it here because I think maybe here somewhere in the bottom I used one function from NumPy to generate some number or something, but it's not that important for you today. It's just this line, and then you see PD comes from Pandas, and it has a lot of functions, because if we go on their documentation page, you can see here, which is on pandas.pydata.org, you can see a lot of functions here, and you also can get learn about all the things from this page. But I just stick on this page here because you can see a lot of functions. Those are not even all of them. They are just specific for topics which are related to input and output. And then you have a lot of other things, like, for example, general functions here. And then you can see what you could do with all of that. And for example, we could check if any data is not null, or if it's null, or to get the maximum. But I will get to that. So let's just say you want to create a data frame. And as I have told you before, it looks a little bit like wait, where is it? Yeah, no, it's not like here, it's here. It looks like a table, right? So that's a data frame basically, but I will show it you here more by taking this dictionary. And that's another thing which you have to understand, that one advantage of working with data frames is that it is, how do you say it? Like, it is usable with all different data structures which you have seen before. And in this case, as you remember, let's close this one for a while. We created this dictionary, right? And now I want to turn it into a data frame, because my data is just too big and I don't want to look at it like this, right? So in my case, I just have like 4 elements, so it's not that big. But imagine your data would be like that, and you want to look at it and understand it, but you can't do it, so you transform it into a data frame. And what do? You go here and say PD data frame, and let's say your dictionary exists like that, right? And then you say, okay, this is my parameter which I put into this function which is called data frame. Pretty straightforward, right? And then I save it into a new variable which is called member details. Because we pretend this is like data of our community, where we say we have those different fields in our community, and if those fields actually are existent, and how many people of our community belong to this field. And now I created this one, and let's see how it looks like. So I press Shift Enter again, and boom, I created this table just out of this dictionary, and this is way better to read, right? Instead of this. Because if I would transform this into a data frame, it would look like this, but it would have different columns and a lot of more rows actually. And this is the first thing you need to understand. Data frames are basically two-dimensional data structures, and to understand it better, just understand that it's a table. Data frames equals tables. And if you take one column out of this table, then you have a series, which is called like a Pandas series, which is the same like a list or array, which you have seen before. Okay, but we won't go that deep today. We just just show you that you now just transform this dictionary into a data frame, and then you can have a better look. And now we want to save all the JSON data or dictionaries which we have here into a CSV file, because if you know, CSV is like a comma separated values. This is like the file CSV, and let me see, CSV example GitHub. Yeah, CSV files. Maybe I find some examples here. What is this? Clever CSV. Is this? Where is an example CSV? Sample CSV here. Look at this. So I don't know if you have worked with CSV files actually, but if you transform a CSV into a spreadsheet like an Excel, it would transform into a table like this one. But if I check the raw file of this CSV, it will look very weird like this. I don't know if you have seen it before, but that's basically how a CSV file is or looks like. So you have values, and they all are separated by comma. That's why, what did I say? It's called comma separated values. And that's basically a CSV. And this also is a little bit hard to look at, right? So imagine you have like millions of data, and you're like, man, okay, how do I filter this, or where can I look at it? It's very hard to read. That's why people import it into Excel, and then you can see it better, understand it, analyze it, and just manipulate it, okay? And now let's say we want to transform our data into a CSV file, because it's a very common way to load your data into CSV files, so you can actually transport them easier, you know? Like I think people in accounting or in the health industry and automotive industry, they still work with a lot of spreadsheets and CSV files. And I also know a lot of people from the blockchain space. I think Blazer and Talpa, they can confirm that we worked with people who basically just worked with spreadsheets, and those are all CSV files, right? And that's why if you have the skill where you can transform your data from data structure one to another one, and have the possibility to transform it even into a CSV file and back and forth, whatever you want, then you also have really good cards to win the project or whatever you want, right? And that's what we want to do. That's why now we have the member details here, so I just can run it again. And here's another thing, guys. If I run this cell here at the top, right, my dictionary, all the other cells which are below that are aware of this variable. It's the same like if you go into your PyCharm and you write a variable at the top, then of course everybody below that knows that, right? And I just can run it again and again and again, and nothing happens. This is the coolest part of that, okay? And now I just want to save and read data frames to CSV files. And you see, I just take this data frame again, which is called members details. And then I just need to understand or know there's a function which is called toCSV. And then I just say, I don't want to have an index because I don't want to have 0, 1, 2, 3 here. I just want to have all the raw data. And then I just save it. And if I don't set a different path, it will just create the file into the folder which I'm at right now. So I just press Shift Enter again. Boom. And now you see it didn't say anything, so it's working. And now I can look into my structure here. And okay, this is from an hour ago. So let me just remove it and do it again. Boom. You see, it just got created. I don't know if you saw that. Let me just do it again. So now look at this page here on the left side. So I created, boom, it got created. And now I also can open it here. And then you see, I suddenly created a CSV file in my own folder. And now I could take this, send it to Talpa, and he can process it and build a front end and take this data and just visualize it, done, right? And that's how many software actually work. So they have some kind of database or whatever that is, and they dump it into a CSV file, and then they work with that. And that's what I just did with you. So yeah, now you know how to transform your dictionary into a data frame and save this data frame into a CSV file. And one advantage of a CSV file also is that it's not that heavy, so you can transport it very easily. And now let's see what else we have here. Now we saved it, and now we also want to read it again. So let's say you have a CSV file from somewhere, I don't know, from a new data source, because somebody's coming to you and says, hey Long, look at this, man. Those are all my members from my community, because I saved them into a Google Sheet, and now I want to take them all out, or you have to work with them and understand who is in this community or whatever that is, and then you have to read it into your Python script again. And that's how you do it, by just saying pandas read CSV, and that's it. You see, I can write into CSV by saying toCSV, and I can read by saying read CSV, nothing more. And then I just have to define the path to this file, nothing more. And then I just can say, okay, I just call it member details df, which is standing for data frame. So I just created, like I have this one, and now I create a new one just from this. Okay, so it has nothing to do with this one. And let's see what happens. So I just read it, and now I have the data here. Amazing, right? That's so simple and easy, and that's why Pandas is so cool. So let's say I want to read this file, and I would say, yo, I don't have this file, man. What is that? You see? Pretty easy. That also was an error message in Jupyter Lab. But let's go further and just do the last part for today, which is to manipulate your data. And for that, I have created this one, for example, here. So you remember the function PD data frame takes one argument, which is basically your data. And in this case, you have to pass your dictionary into this field or as an argument, and then you can transform it into a data frame. And in this case, I won't take this dictionary, but I will create a random generated dictionary, which you can see here. So this dictionary consists of two keys, which are A and B, and they have two rows each, which is 1 and 2, 10 and 20. But let's see how it will look like. So I will go here, and you saw I just cut my cell into two pieces, and then I can say df just to print it so I can see how it looks like. Boom. Now I just created this dictionary, or put this dictionary into my data frame function, and then created another table. And now I could say, okay, let me just create another one, C, and then I say 100, no, I say 11, no, or whatever, 22, 11, And then do it again. Now I have A, B, C, 1, 10, 11, 2, 20, 22, as you can see. This is always the first row. This is the second row. So you have to get used to this, this way of data visualization, like that this array will become a row. But if you work with data frames, you will get used to that. So let's continue and actually do something with that, right? So let's just close this, clear outputs. And I now want to show you that how you can manipulate your data. And by saying that, I mean that let's say I have this data frame again, and I want to add, or I want to do something with all those values. And in this case, I want to multiply it by itself. So take the square of this number, like of each of them. And remember, this is just the index of your row. So this is my first row, this is my second row, and it starts by at 0. And now I take, or I create a function first, which basically just takes an input, a number, and then it takes them or returns the number by multiplying it by itself. That's basically what this function is doing, which is called square. And now I want to say that each value of this data frame should be squared. And to do that, I just have to say the data frame, which I have here, data frame dot apply. And apply basically takes this function, because normally, when you write a function, you have to, or call a function, you have to write the name, and then you open up brackets, and then you have to pass an argument like 5 or something like that, right? But here in the apply function, you don't need to do that. You just have to write the name of this function here. That's why it doesn't have all of this. And then what it does is it goes to all different rows and actually values of this table and applies this function on each of them. Okay, that's basically what it does. You don't need to understand it fully now. You just need to understand that it's so simple to manipulate your data with just one function. Okay, so let's see what it does actually. So I said data frame apply the square on each number, and then save the data frame into a new data frame, which is called data frame 1 or squared actually. And then I print it again, boom. And now you see this was the old one, 1, 10, 11. And if you square 1 with 1, so 1 times 1 is 1. And if I take 10 times 10, of course, it's 100. And 11 times 11 is 121. Yeah. And now let's see if it is the fact. So I said this should be 1, 1. 10 times 10 is 100. And 11 times 11 is 121. Amazing. So, and now also it did the same for the numbers here below. So 2 times 2 is 4, 20 is 400, and 22 times 22 is 484 apparently. And you just did this one. And now imagine you don't have just like 2 rows, but you have hundreds of rows or millions of rows. And you want to apply this function on all those rows, then you just have to call this one, create your own function, what should happen with each number, and then you're done. So let's say I want to return a self-def class. So let's see if that actually works. So I want to take it. It doesn't matter what I will do with that. I will just return self-def class, and I want to have all of those values replaced with self-def class. So let's see if it works. So you see, now it says A self-def class, B self-def class, C self-def class, nothing more. So I just replace numbers with a string, or just like xxx, whatever that is. Now it's all xxx. But let's say x plus 10, and now all of the numbers got plus 10, whatever that is. You can do anything. And this is just the beginning, because it can be way more complicated, but this is just a very simple example, because I just want you to understand how simple Pandas actually is. And now let's say I have the data frame and rename it to df1, and I want to get the average of each number or each row, whatever that is. So let's see what will happen when I say the mean. And now it showed me from A, the mean is 2.5, and from B it's 250, and C it's 302 or whatever that is. And let's say, wait, let me actually do this again and this one. And because data scientists always care about those metrics, but let's say I want to get the maximum of each row. What is that? df1, okay. So look at this. So first I squared all of them. So let's do this actually again. So you see what happens here. So I squared each of them. Here I have my old data frame, this one. I squared it here and returned it to df1. And now I wanted to check the maximum of each column. So A, the maximum here is not 1, but it's 4. That's why it just returned me 4. And then for the next one here, B, it's 400. That's why it returns 400. And then for C, it's 484. That's why it returned this one. And if I want to get the minimum, I can do the same. And imagine you have millions of data. How fast it processes all of that and finds the smallest number of each column for you. And now imagine how you do that with dictionaries. I mean, there are functions how to do that, but I don't believe you can just write like this small function and then you have it. You have to write way more, and that's why Pandas can help you to save so much time, right? And that's why I wanted to introduce it to you today. And the last part of today's class is basically another example that I have this data frame. So let's say I have this data frame based on this dictionary, which has a task handed in. So you will see how it looks like actually. So you see, just by looking at that, you don't even know what that is, or I don't know what that is. But if I transform it into a data frame, I instantly know, okay, so I have a task or task column and hand it in. So because I want to show you how many tasks a user did already and how many they handed in. And in this case, we have Blazar who did 8 tasks already and handed in 7, and Tess did 10 tasks and handed in 8. And now I have this data frame, and let's assume you have a lot of data, you manipulated it, you removed something, you added a lot of different columns or whatever that is, and you need to continue working with a dictionary because your front-end team actually takes a JSON object so they can visualize all the data, because they don't I don't think that a lot of front-end developers work with data frames, because data frames is a very Python-specific data structure which has been created just for the purpose of working with data, right, in Python. So somebody who writes TypeScript or React code, whatever that is, they won't work with data frames. That's why you have to transform it back, or be able to transform your dictionary, your data frame into a dictionary that way. And now what do? I take this data frame and say to dict. You remember we wanted to make it into a CSV. We said to CSV, and now we say to dict. And now let's see what happens. New dict, boom. Now I took the data frame, created a dictionary out of it again, done. Or let's say df drop. Oh no, let's apply something. Apply square again. So you see, now we have all those numbers because it got manipulated. We added on top of that something. And now I say I want to add it again here. And oh, of course, I have to say data frame equals data frame applies, because I need to do that and how do you say it, assign the new data frame to a new variable. And in this case, it's just the same. So I just replace it with the new data. And that's why it looks like that. And now I say, okay. Oh, wait. You do this. Yeah. And now you see we have the new dictionary here from the manipulated data frame. And now you basically know how to transform a dictionary into a data frame, and then a data frame into CSV, or read from it, save it, and also turn it back into a dictionary. And this example, or those examples, are a little bit well, they probably won't convince you to start working with data frames, but when you work with a lot of data, which are like over 10,000 of objects or whatever that is, you need another way to handle your data and to understand them. That's why I introduced you to data frames, and I hope that gave you some insights. And what do I have here still? More resources to learn. So I added it here, and of course this whole file, this new Jupyter Lab or Jupyter Notebook, will be part of task number 14, so you can reread all of that. You can download it, and then you can just run it yourself, and then you see it for yourself, right? And let me just remove this part here so you don't have that. And that's basically it for today. And you now should have a gist about Pandas data frames. And if you want really to know more about that, just go on any of those pages which I dropped down below. Then you can check everything. You can merge different data frames to each other. You can save it into a dictionary, send it to somewhere else, and or like via over servers. So another script gets the data, and then you can transform it back to a data frame and dictionary, whatever it is. That's why data frames are so usable and so handy to work with. It also can just detect all the specific values you are looking for. Like, for example, let's see, what did I say? It should drop all the values which are none, or which are one or true, you know, like none, null, whatever you want. So there are a lot of functions which you can use with Pandas, but now you just have heard about all of that, and maybe you will work with that in the future. And that's it for today, guys. So I hope that was some kind of insightful, and yeah, whenever you work with a lot of data, remember data frames, and go back to this video, watch it, or just go into the documentation and check it out. And thank you for joining, and don't forget to like, subscribe, and comment down below if you have any questions, and join our Discord server if you want to learn more about Python, or if you have any questions about tech and programming. We are a community with a lot of tech enthusiasts and programmers. And that's it for today, guys. So thank you for watching, and see you next time. Peace.